Hello, welcome to the classroom. So today we will see about a subject called logic design, and also sometimes this subject is called digital electronics. So very basic subject about digital electronics. So why this subject is important? Because all the digital circuits you see, so this subject is important for all the digital circuits you will see. If you want to understand all the digital circuits, if you want to understand how microprocessor work, so this is important for understanding how microprocessor work. This is also important for understanding how microcontrollers work. You can see a lot of microcontrollers in daily applications. Apart from that, this is also important for memory part. So memory is also very important part of computer. Basically, you will, after seeing this video, you will know how your computer is working. That is the main idea behind this. How your computer is working. So let's see what we will learn here. So the basic thing is about gates. So first you have to understand what is gates, and before gates you have to understand what is a transistor and why transistor is so important. So we will not go deep into the working of transistor or the working of transistor in kind of a detail, but we want to know the application part of transistor. What is the application part of transistor? That is more important for us. So if you see the application part of transistor, so what you can see here is transistor was invented in 1947. So what transistor does in our application, especially in computers, so what transistor does is it is used as a switch. So why do you need switch is you will understand when you understand gates. So let's see, we try to discuss gates now. So let's see, you have three basic gates. So basic gates, you have three basic gates. You have AND, you have OR, and you have NOT. So when you understand the basic gates, you understand why do we need transistor and why transistors are important for computers. So in basic gate, if you know about AND, so AND is 1 when both the inputs are 1. So what is the basic logic of AND? So you consider a wire, and this wire is having or is broken from two places, and this is your input side, or a battery is connected here, and this is your output side. Now if you want your current to reach from the input to the output, you want both of these switches to be closed, right? So if you close these two switches, then only your input current will reach the output, or then only this positive battery will reach at the output. That means then only your output will become 1. So instead of manual switches, what is the characteristic of transistor? If you see, so this is a transistor, you see, So this is the base part of transistor, this is the emitter, and this is the collector, right? You can see here base, emitter, collector. So what is the characteristic of transistor is, if this base is 1, then whatever battery is connected on the collector side, it will allow the current to flow in this path if the base is 1. And if the base is 0, it will not allow this current to pass through collector and emitter. This is the basic characteristic of transistor. This basic characteristics we will use as a switch here. This is the application part. So if we connect transistor in such a manner like this, if we connect transistor like this, and here if we connect transistor like this, then I can make use of this characteristic of the transistor. So what I can do now is, now this is where my battery is connected. So if I want 1 on this side and these are my 2 inputs bases, then when I give 1 to A, then it will pass this current. When I will give 1 to B, then it will pass this current. So this VCC will reach here, or this 1 will reach to the output. So this is basically your input and this is output. So this VCC reaches the output only when both conditions are true, or when both transistors are on. So this is the basic circuit or basic idea of AND. But you see AND gate like this. So these are the 2 inputs and this is the output Y. So Y is equal to A and B. So always remember, this is the logical diagram. This is the logical diagram, not the actual diagram. Actual diagram is like this. This is the logical diagram of AND. So why do we need this type of diagram? To study the circuits, we need this type of diagram. But in actual, when you make AND gate through transistors, you will make it like this. Now coming back to the second gate, which is called the OR gate. So when you make OR gate through transistor, the circuit will look like this. So here you will have your input, here you will have your output, and you have at 2 places the wire is broken, so you need switches here. So instead of switches, you connect 2 transistors here. So let's say this is your A and this is your B. So these are the 2 bases of the transistor. When you give them value 1, then only your input will reach output. So if the battery is connected here, so this battery will reach at the output when any one of these transistors are on. That's why OR gate's logic is, when A or B is on, then only the output is 1. Right? So similarly, the last one, you have NOT gate. So in NOT gate, you need only 1 transistor. So this is your VCC and this is your transistor and this is your base. So this is grounded and here you are taking your output. So when you make your base 1, let's say this is A. So when you make A1, so this whole VCC will get grounded here and output will be 0. And when you make A0, so this will be off and the whole voltage will go here, so the output will become 1. So you represent NOT gate by this type of symbol, which is a logical symbol, but the actual circuit is this. Similarly, you represent OR gate by this symbol, but the actual circuit is this one. So this is the basic idea of how the gates work and how their actual circuits are. Then you make these circuits, or you make the AND circuit inside the IC, and then from there you can use them for practical applications. So always remember all the digital devices you see. So there are two type of digital devices which are important. So in terms of computer, if you see, so you will have one part which is called as CPU, and the other part in the digital device you call as memory. Okay, so we are basically talking about the RAM memory right now. So you see, your CPU will be connected through wires to this memory. Now you can make the elements of CPU through these gates, and also you can make your memory through these gates. So we are talking about only these three gates, AND, OR, NOT. So all the digital devices of CPU and memory you can make through these gates, and these gates you can make through transistor, as you have seen. So this is the basic idea. So from transistor actually you can make CPU, and from transistor you are actually making memory, which is RAM. So that's the basic idea. That's how your transistors are making processing device. That's why when you have more and more and more transistors on your ICs, you have much better CPUs, and you have processors, and you have much better RAM. So that's the basic idea behind the digital devices, behind the transistors and in these gates. So you can say that we have other gates also, like NAND or NOR or XOR or XNOR. So you can say that we have seen all the circuits through these gates, not by these gates, but if you think, all these gates are part of these three gates. So nothing extra is connected here, only these three gates are connected here. So that's why these gates are called basic gates, and you can see them in all the circuits, in all the digital circuits. So that's it for now, and please join us for the next class where we will discuss something more interesting like this. Thank you very much.